Hey everybody! So the question we're going to work on together today is this question called non-overlapping intervals. So I think this is a really great question to start with because it's one of those classic problems that can be solved with a greedy approach. And also intervals are a common thing to encounter in different kinds of questions. So it's great to get familiar with how to work with intervals and knowing the ins and outs of them and how to go about approaching solutions and problems that involve having to work with intervals. So this is the question we're going to work on today and try to solve. So let's first start by trying to understand the question. So the question states that given a collection of intervals, we want to find the minimum number of intervals to remove to make the rest of the intervals non-overlapping. The couple notes we are given here says the first thing is that we can assume that the interval's endpoint is always bigger than the start point. And the second note says that intervals like 1, 2 and 2, 3 are bordering each other, but that isn't considered overlapping. So this would be a time where if we were in an interview, the interviewer would probably give us some examples to give us a better understanding of what we're trying to solve. So let's look at the examples that we have from here. So for the first example, we have an input with 4 different intervals, 1, 2, 2, 3, 3, 4, and 1, 3, and we want to output 1. Why do we output 1 in this case? Well, 1, 3 is the interval that intersects with both 1, 2 and 2, 3. But if we remove 1, 3, then the rest of the 3 intervals don't intersect at all. And that's why we output 1, because 1 is the number of intervals that we have to remove to make everything else non-overlapping. So taking a look at the second example, we have 3 of the exact same interval. And in this case, we definitely have to remove 2 of the intervals because otherwise, we would have intersecting intervals completely. So we have to remove 2 of them, and we're left with one interval, 1, 2, that's not intersecting. And for the last example, we have 2 intervals, 1, 2 and 2, 3. And we output 0 because while 1, 2 and 2, 3 border each other, they don't necessarily satisfy the requirement of being overlapping. So we don't have to remove anything for this set of intervals to have nothing overlapping. So that's great. So this is the part of the interview where I would usually try to come up with some of my own example input and output cases. First of all, this is a great way to validate with the interviewer that what I'm trying to solve is what he wants me to solve, and we're on the same page about what the problem is and what the solution should be. So this is a great time to come up with your own input and output examples, and then verify with the interviewer that it's what they expect as well. The second thing that I like about coming up with my own input and output examples is that I get to think through the problem myself. And while I'm thinking through the problem and coming up with what the output should be for a given input, it usually gives me a better understanding of how to approach a certain problem. So that's what we're going to do now. We're going to try to take this question and we're going to come up with some of our own inputs and then work through our own inputs to figure out what the output should be. So, I usually like to start off my own inputs with something simpler and kind of work from there. That way I get a better understanding of how to build up the question as it gets more complicated and what to do from there. So the first example is, what if we just had an input of 1 interval of 0, 3? What would you expect the output for this to be? So since we only have 1 interval, nothing intersects, so we would expect the output to be 0 because we don't have to remove any intervals for this set of intervals to be non-overlapping. So that was pretty simple. So now let's move on to something a little more complicated. What if instead we want our input, what if instead our input was a set of 2 intervals, 1, 3 and 2, 4? What would you expect the output to be for this example? So since 1, 3 and 2, 4, since these 2 intervals both intersect with each other, we definitely have to remove one of them. So I would expect the output to be 1. We could either remove the 1, 3 interval or we could remove the 2, 4 interval. Either way, we have to remove one interval for this set to be non-overlapping. So I would expect the output to be 1. So these are pretty simple so far. So let's go with a little more complicated example. What if we had a set of 3 different intervals, 1, 3, 2, 5, and 3, 8? What would you expect the output to be in this case? So at this point, it's a little hard to visualize sometimes when it's just numbers written down. So what I like to do is draw out line segments that represent what the intervals would be if we had a visual representation for them. So in this example, we had 1, 3. which looks something like this. And then we had 2 comma 5, and then we had 3 comma 8. So when I draw out intervals like this, it's easier for me to visualize what's happening, and it's easier to see which intersections are happening or overlaps happening and which interval I could take out to make things non-overlapping. So when I draw this example, it becomes a little more clear to me that if I remove 2 comma 5, I can have 2 separate intervals that are not overlapping, 1 comma 3 and 3 comma 8. So I would expect the output to be 1 in this case because the only interval we have to remove is 2 comma 5. So the interesting about this particular example, I think, is yes, we can also remove 1 comma 3 and 3 comma 8 and be left with just the interval 2 comma 5 here. But if you remember what the original problem states is, we want to find the minimum number of intervals to remove. So we can't just optimize on removing as many intervals as we want when we see something that overlaps. We want to remove the minimum number of intervals. And the reason for this is because if we didn't have that constraint, we could really just remove all the intervals except 1. And that would always be non-overlapping, right? So that would make the question a little bit easier. And with this constraint where we want to always remove the minimum number of intervals, this makes this question a little bit harder. So this is what we came up with this solution. But the way that we visualized it and kind of just came to the conclusion that we should remove the interval 2 comma 5, let's try to put that into words a little bit. So how do we formalize what we saw on here into pseudocode? So how can we extract our thought process and put it into pseudocode so that we could maybe translate it into code later? So the way I kind of looked at it is my brain processed everything really fast, but if I slow it down a bit and took a look at the steps that I take to realize that I have to take out the 2 comma 5 interval, it was kind of like I looked at 1 comma 3. It didn't overlap with anything, so I left it alone. And then my brain went to the 2 comma 5 interval. I saw that it overlapped with 1 comma 3, so I was like, okay, let's take that one out to satisfy our constraint on not having any overlapping intervals. And then I went to 3 comma 8. And since we already took out 2 comma 5, 3 comma 8 didn't intersect with 1 comma 3, so I didn't remove it. And that's how I, in my mind, ended up with 2 different intervals that didn't intersect with each other, and knowing how I wanted to take out one interval. So that's great, but if you look at our input from this example, it was nicely sorted for us, and it just happened that with our thought process, it worked perfectly, where we could iterate through the list of intervals we were given, and if the interval we're currently looking at overlaps with the previous one, then we removed it. So this worked great because the input we're given was a very nicely formatted input where we could go through this process. But if we go back to the question statement, nothing about this question states that our input is going to be given to us in some sort of form or order. It just says given a collection of intervals. It doesn't say the collection of intervals will be given to you in this order as always promised, or this collection of intervals will be sorted in this order as we promised. So it doesn't state anything about that. And one of the common approaches for approaching greeting problems is that you have to find some way of manipulating the input in a way where you can approach it with a greedy algorithm. So many times you want to find some way to be able to sort the input in a certain way that would allow you to be able to greedily take inputs as you're iterating through the list. So for this example, our input could have been any of these 3. We were just very lucky that what we had was 1 comma 3, 2 comma 5, and 3 comma 8. But it really could have been anything. 3 comma 8 interval could have been first, the 2 comma 5 interval could be first, and these would all have to have the same output because no matter what our input is, we always have the same output for what the minimum number of intervals we want to remove is. So these all have the same output, but they're coming into us in different orders. So let's take a look at one of the specific examples to see if our thought process and the pseudocode that we came up with previously would still work given that these orders are jumbled up a little bit. So let's take a look at the third variation of these intervals, where we have 2 comma 5 and then 1 comma 3 and 3 comma 8. So again, it's a little easier to visualize once we can draw out the lines. So in line form, it will look something like this. So this is the same thing we had previously, but the orders are a little jumbled. And if we try to go about this problem with the same approach that we did before, so what we did was we looked at 2 comma 5, and then we said, okay, let's look at the next one. 1, 3. Does that intersect with 2, 5? And yes, it does intersect with 2, 5. So we're going to remove it. And now we're going to look at 3, 8. Does it intersect with 2, 5? So again, it does intersect with 2, 5. So now we ended up removing 2 intervals when really we should just had to remove 2, 5. So this presents to us the problem with, oh, maybe now we have to think about our input and how we could sort it in a way that will be beneficial to us later so that we could easily iterate through them. So the question now is, we have to sort the intervals first. So now our pseudocode and plan has changed up a little bit. So before we iterate through the list and look at intervals that overlap with each other, we want to sort the intervals first so that we can do the second and third steps correctly. So the hard question always becomes, how do we sort our inputs? There are many ways to sort intervals, so we want to figure out what the approach we want to take is that would work for us. So there are 2 different approaches that we could take for sorting inputs. So for intervals have a start value and an end value. So we could either sort it by the start value or we could sort it by the end value. When we're sorting by the start value, we could probably go from min to max, and same thing for the end value, where we go from min to max. But which one of these approaches should we take, and does it even matter? Well, let's take a look at some examples to see if we could get a better understanding of which approach we should take. So the first option we have is to sort by the start value of the interval. So, given our original input, if our original input was 2, 3, 1, 1000, 4, 5, and 3, 4. If we sorted this based on the start value from min to max, we would end up with the line here, where we have the 1, 1000 first, and we end with 4, 5. So given that this is our sorted input, and we went through the same approach where we iterate through the list, and then took out intervals that intersect with each other, would this work with the current algorithm we have? So the problem with this approach is that we want to output 1, right? Because ideally, we just want to remove 1, 1000. Then the rest of the 3 intervals would not be intersecting at all. But the problem with this approach is, if we're going with what we previously came up with, what we're doing is we will look at 1, 1000, and then we go to 2, 3, which does intersect with 1, 1000. So we take out 2, 3. Then we look at 3, 4. That also intersects with 1, 1000. So we end up taking out 3, 4 too. And then we look at 4, 5, which also intersects and overlaps with 1, 1000. So now we ended up taking the last 3 intervals instead of just taking out the first interval, which is not what we want because we wanted the minimum number of intervals we could take out. So this kind of sorting doesn't seem to work too well. There are obviously cases where this kind of sorting would work. So for example, if instead of it was 1, 1000, we had 1, 2. Then this kind of sorting worked great because we would just iterate through the list, nothing intersects with each other, and we return 0. But in cases where we have a very long range for the first interval we're looking at, we would end up taking out too many intervals past it to the point where we should have just taken out the very long range. So how can we improve on this with our sorting algorithm? Let's see if our second idea for how to sort inputs could work a little better. So our second idea for sorting inputs was to sort by the end value instead of the start value. So given that, our original set of intervals was this. So what would you expect the output of this to be, given that we want to sort it by its end value now? So given that we're sorting by the end value now, we would expect our sorted output to be 2, 3, 3, 4, 4, 5, and then 1, 1000. So that's because we're just looking at the last value for each interval and sorting it in increasing order, and that's how we get this. So with this approach, would it still work if we were going through our original method of looking at a certain interval and the previous interval before it and seeing if they intersect and then removing one if they do intersect? So looking at this approach, let's walk through our example. We go to 2, 3, that's fine. 3, 4 doesn't intersect with 2, 3, that's fine. So then we go to 4, 5, it doesn't intersect with 3, 4, we don't remove it. We go to 1, 1000, it does intersect with 4, 5. So now we end up removing 1, 1000, which is exactly what we want because now we're removing just one interval out of these 4 to make the whole set non-intersecting. So that's great. So now we've come up with a more detailed solution of how we think we should sort the intervals. Because our first bullet point was just sort intervals. That was kind of vague for us, and we didn't really iron out the details in the beginning. But now we have, and now we know how we want to sort intervals. So how we want to sort the intervals is by the n value of each interval. So now our plan becomes sort the list of intervals by their n value from min to max, so in increasing order. Then we iterate through the list of intervals we have, the sorted list of intervals. And while we're looking at each interval, if the interval we're looking at overlaps with the previous one, then we remove it and keep a count. And in the end, we return how many intervals we had to remove as we were iterating through the sorted list of intervals. So at this point, what would you expect the runtime and run and space-time complexity to be? So sorting the intervals is going to be n log n time, as efficient as it can get. Iterating through the list of intervals is going to take n time, and we are keeping track of some variables, but we're not necessarily making a new list of intervals, so we're not really taking up much space except O of 1's, because we're just storing variables. And our runtime complexity would be sorting the intervals, which is n log n, plus iterating through, which is n. So n log n plus n kind of simplifies to n log n in the end. So I would expect this algorithm to run in n log n time, mostly because of the sorting, and it wouldn't take up constant space because we're not storing anything except a few variables to keep track of what we've seen and what we didn't see. So given these three steps that we have, this is kind of pseudocodey. So now let's try to turn it into code. So I'm gonna copy what I have here and put it down here as comments so that I could work from this. So these are mostly the 3 steps I want to take. So when I have this pseudocode ready and I know what my plan is going to be, I like to usually mock out some helper methods that could simplify my code and also give me a better way to understand what's going on with my code. This way the interviewer can easily read my code and hopefully be able to understand it better. And it also gives me a more organized way to both debug and explain to the interviewer my thought process. So what are some great helper methods that we can use or implement for this problem? So the first one is sort intervals by n. So that sounds like a great helper method to start with. So it'd be great if we had a method called sort intervals by n value. It's very verbose, but also very descriptive, so I like it. So we could just kind of leave that unimplemented for now, just kind of stubbing out helper methods so we know what we need and what we don't need, and we could easily go through the code and iterate through that. The next thing is we want to iterate through the list of intervals. I can't think of a good helper method for that. It's probably just going to be some kind of for loop or while loop. The third point we want to do is if the interval we're looking at overlaps with the previous one we examined, then we want to remove it. So right from this comment, I want to say it'd be great if we had a helper function that says overlap. Given 2 intervals, does these 2 intervals overlap? So this method, while I didn't implement it yet, would tell me if 2 intervals overlap each other. And that would hopefully help me with the third bullet point I'm trying to do here. So turning pseudocode into actual code now, even though I haven't actually mocked out my helper methods, I could still call them right now just to get an idea of how this is going to work. So the first thing is we want to sort the intervals. The next thing is we want to iterate through the list of intervals. So there are a couple of different ways to go through this. I could either just write a for loop and automatically go through every interval in the list, or I could keep a manual count. I usually like to keep a manual count with the indexes just because this is mostly more flexible, where I could access different elements directly and I could keep a track of which element I want to access. So this would be something like Alternatively, I could have done something like this. That's basically the same kind of for loop right now, but I wanted to do the second approach here where I'm keeping track of the indexes manually just so it could provide me a little more flexibility, but different kinds of situations could call for different cases. So while we're iterating through the list of intervals, if the interval we're looking at overlaps with the previous one, so this is a great time to use our helper function overlaps. So if the interval we're looking at overlaps with the previous one, then we want to remove it. So we don't necessarily want to remove it because we're not trying to return a list of intervals that aren't overlapping. Really, we just have to return the number of intervals we have to remove. So this signals to me that maybe we should keep a count of how many intervals we have removed so far. And increase this count every time we see an interval we do want to remove. So if the interval we're looking at overlaps with the previous one after our sorted list, then we probably want to increment the count we have seen. Otherwise, if it doesn't overlap with each other, it doesn't seem like we need to do anything. So now we could kind of move this comment here to make it a little more clear. And we're not removing it anymore, really. We're just increasing the count of intervals removed. And in the end, so I'm missing a parenthesis here, but in the end, what we want to do is ultimately return the intervals removed. So this looks okay to me right now, but I'm seeing a problem where we're not quite keeping track of which interval to look at. So given that we're going through the intervals one by one, this can become a problem if we start to see an interval removed. Even if we remove an interval, we're still comparing it with the one, we're still comparing the next one to this one, which is not what we want. So to get a better understanding of what I mean here, if we went back to this example, what would happen is we would look at 1, 3 of the interval. That's fine. We look at 2, 5. We realize that 1, 3 intersects with 2, 5. We remove 1, 5. But when we look at 3, 8, we're comparing it with 2, 5 again. And that's problematic because now we're going to say 3, 5 intersects with 2, 5. And then we're going to end up removing 3, 8 and 2, 5, even though we already removed 2, 5 and we didn't have to compare it to 3, 8. Instead, we should have compared 3, 8 to 1, 3. So how can we kind of fix our algorithm to keep track of something like this? So it seems to me like we should also keep track of what the last interval we actually didn't remove was. So So what this means is I want to keep track of which interval I want to compare the current one to. So instead of comparing the current one always to the previous one, it would be better if we compared it to the last valid one we had. And at the same time, when should we increase this valid index? So if we're looking at 1, 3, and then we go to 2, 5, it does overlap. So now we don't want to count this anymore. So we want to keep going with this. Keep comparing the next intervals with 1, 3. So we don't want to increase the index when we remove something. But when we see something valid, so for example, if we see 3, 8, and it's valid because it's not intersecting with 1, 3, then we do want to increase the index so that the next time we compare an interval, it's comparing with 3, 8 and not 1, 3 or 2, 5. So in that case, whenever we see something that doesn't overlap, so if we're in the else case, this means that the interval is valid and we don't have to remove it. So if we're in this case, then now this signals to me that we need to update our last valid interval index. So we can't always just simply increment it, because if we simply incremented it, then what happens is, so we can't just simply increment it, because if we just incremented it, what happens is we're gonna end up looking at the wrong interval. So if we're at 1, 3, and we go to 2, 5, and then we go to 3, 8, if we simply increased it, we would end up comparing the next one with 2, 5, which is not the right interval to compare it. So instead, we want the next interval to compare it with the current interval we're at. So that means we should set last valid interval index to I. So this seems like a great plan to me so far. We got the pseudocode down, and we translated some pseudocode to actual code, and we stubbed out some helper methods. So the 2 challenges left for you here is to figure out how to determine if 2 intervals overlap. So figure out what would go in this helper method. And then the second thing is how would you sort intervals by n value? So this is a very common thing in Java where you have to sort something in place. And since we're given an array, it's pretty common in Java to do something like arrays.sort, and you're given the list of intervals, and you create your own comparator. Something like this. And then the thing you want to customize is the compare method. So given 2 intervals, how can we determine which one goes first and which one goes last? So luckily for us, we wrote out our method with a very descriptive name. So we wanted to store the intervals by n value. So your challenge here is to figure out how to store the intervals by n value using this compare method. So given these 2 intervals, what do you want to return? So this is a great exercise into looking into how arrays.sort works and how the comparative function works and how to implement the compare function to output what you expect. And the second thing we want to do is figure out how to determine if 2 intervals intersect each other. So hopefully these 2 methods are pretty straightforward, but the rest of our boilerplate code is here. And once you get everything done, it'd be great to try to walk through your solution, one of the custom examples that we came up with, just to make sure that it works. And oftentimes you'll find that there's an off by 1 error or you're missing something. So in this case, the one off by 1 error I could state is we shouldn't start at comparing the first interval with itself. Because what happens here is we're going to end up comparing the first interval with itself, and we're always going to see that it overlaps. So this should probably be a 1. The second thing is we haven't considered what we want to do when the intervals have the same n value. We simply said sort intervals by n value. But what happens when the n values are the same? How do we want to compare them then? How do we determine which interval should be sorted first according to the start value? So that's another thing to figure out. So once you've got all that figured out, it'd be great to run through an example input that we had before and determine if that works with our solution, and then run your code and see if it works. So hopefully that was a general overview of how to approach this problem and how we went about setting up the solutions, mocking out the pseudocode, turning the pseudocode into actual code, making sure that we have appropriate helper methods that makes our code easier to read, and then going from there to then finally implementing it and then running through your solution with an example.